Greetings and welcome to lecture 1.2. In this lecture we'll be discussing real numbers and properties of real numbers. So let's visualize real numbers. We have a real number line here drawn on the page that goes from -4 to +5. The 0 marker is our origin. Then everything to the right of the origin is going to be positive. Everything to the left of the origin is going to be negative. Now, the key is I said to the right of the origin and the left of the origin. I didn't mention the origin. The origin is neither positive nor negative technically. But if you want to throw it in, it doesn't have a sign, so maybe you say it's positive. Let's run through some terminology. The coordinate would be the number associated with a point on a real number line. For example, this point on the number line that I just highlighted is the coordinate of a 4. If I choose another point on my number line, the coordinate of that point would be a 1. And the coordinate of this point is a -3. Real numbers are numbers that can be expressed with a point on the number line, on the real number line. That includes whole numbers, fractions, decimals, positive and negative. Fractions, on the other hand, we have a very explicit definition of fractions. Fractions, if we use the numbers a and b, are real numbers in the expression a over b, where b does not equal 0, is called a fraction. The top number we call the numerator, the bottom number we call the denominator. Now, I say division by 0, we're going to call it undefined at this level of math. That doesn't mean that we can't divide by 0. In a higher level of math, you'll learn how to do that. In this level, we'll just call it undefined, literally the word undefined. So what does a fraction mean on the number line? If I have a number line, and my number line goes from 0 to 1, if I break it apart into 3 equal parts, my first 1/3 will be 1/3 of my whole 1. My second will get me up to 2/3, and my third third will get me up to 1. Now, another way of writing 1 will be 3 over 3. If I continue this pattern, 1 over 3, 2 over 3, 3 over 3, my next one would be 4 over 3, 5 over 3, and so on. I can also take from 0 to 1 and break it up into 6. My first 6 would get me to 1/6. The second 6 would get me to 2/6. Third will get me to 3/6. Next one, 4/6, 5/6, and 6/6 we also write as 1. That is called an equivalent fraction. So if I draw 3 perfectly aligned, now I know it's difficult for me, but perfectly aligned number lines where the zeros are right on top of one another, the ones are right on top of another. The only thing that's different is how I divide up between 0 and 1. The first one I divided up into 3s. The second line I divided up into 6 parts. The third line I divided up into 12 parts. I have equivalent fractions on each of those lines. For example, 1/3 is equivalent to 2/6 is equivalent to 4/12. Visually, they all line up one on top of one another. Likewise, with 2/3, 4/6, and 8/12. They are equivalent fractions. They represent the same number on the number line. We also have some properties regarding fractions. How the equivalent fraction kind of comes about is if I multiply the numerator and the denominator by the same non-zero number, it never really changes the value of the fraction. It might look different, but it's the same value. For example, if I take 1/3 and multiply both the numerator and the denominator by 2, 1 times 2 is 2, 3 times 2 is 6. It's the equivalent fraction. Likewise, if I take 2/6, multiply both the numerator and the denominator by 2, 2 times 2 is 4, 6 times 2 is 12, I'll get the same equivalent fraction. All of these, the 1/3, 2/6, 4/12 are all equivalent. Likewise, if I divide the numerator and the denominator by the same number, it doesn't change the value of the fraction. It might, again, change the way that, it will change the way that it looks, but it's not going to change the value. So I'm going to take 8/12 and I'm going to divide it by 2, both the numerator and the denominator. 8 divided by 2 will get me 4. 12 divided by 2 will get me 6. That's the equivalent fraction. Let's do it again. 4 divided by 2 is 2. 6 divided by 2 is 3. That gives me the equivalent fraction of 2/3. One more property we have at our disposal is the multiplicative identity. That means if I take any value whatsoever, a decimal, a fraction, a whole number, if I take that number and I multiply it by 1, I'll get the same result. So a times 1 or 1 times a will be the same as a. It doesn't change my value. It's the multiplicative identity. Let's refresh on the absolute value of a real number. Well, the absolute value of a real number is its distance from 0 on the number line. If x represents any real number, then the absolute value of x is written as x in between two straight lines. For example, it is read the absolute value of 5 equals 5. The absolute value of negative 1/2 is 1/2. The absolute value of 1 minus 3, well, we have to do what's inside first so we can tell what numbers it's sitting inside there. 1 minus 3 is negative 2. So the absolute value of negative 2, well, how far away is negative 2 from the origin 0? Well, it's 2 spots. Opposites. The opposites of number is the same distance from 0 but in the opposite direction. For example, negative or positive 2/5. Well, that's 2/5 away from 0, but it's to the right. So I went to the right for positive distance. So I went to the right. So the opposite of 2/5, I start at 0 and I go in the opposite direction, so it's going to be negative 2/5. Likewise, if I went to the left 3 spots to get to negative 3, I'll have to go to the right 3 spots. Therefore, the opposite of negative 3 is positive 3. If I went to the left 472 spots to get to negative 172, then my answer of the opposite is going to be positive 472. And I apologize about my writing. I'm not very good with the pen yet, but I'll learn. And then the last one is going to be, well, I went in the right direction, a positive 130.7. Now I have to turn around and go the other direction, so my opposite will be a negative 130.7. So that's opposites. Let's talk about reciprocals. And you may have learned this as in you just flip them a number over and that's your reciprocal. But there is a true definition to reciprocal. It is two numbers that when you multiply those numbers together, it equals 1. So let's refresh on multiplying fractions. When we multiply fractions, we're going to multiply the numerators to get the result for the new numerator, and then we're going to multiply the denominators and get the result for our new denominator. For example, 3/4 times 5/7. 3 times 5 is 15, 4 times 7 is 27. So if we multiply 3/4 times 5/7, our result is 15/28. What happens if it's a whole number? Well, for a whole number, I can rewrite it as the number over 1. Now I can go back and I can say, oh, I'm just going to multiply my numerators and multiply my denominators. So 7 times 1 is 7, and 1 times 3 is 3. When we're multiplying, when we're raising it to an exponent, that's the same thing as expanding it 2/3 times 2/3 times 2/3 if I have 2/3 cubed. Well, 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27, so 2/3 cubed is 3/27. Now let's think about this. Let's find the reciprocal. So 5, the reciprocal of 5, well, that's really 5 over 1. The reciprocal is going to be 1/5. Why? Because 5 times 1 is 5, and 1 times 5 is 5, and 5 over 5 is 1. Well, 2, let's try the next one. 2, that's really an implied 2 over 1. 2 times 1 is 2, and 1 times 2 is 2, therefore it's 1. So our reciprocal of 5 over 1 is definitely 1 over 5. Our reciprocal of 2 over 1 is definitely 1 over 2. Now let's think about it the opposite way. 1 over 3. Well, again, if I use that trick of just flipping it, that's going to be 3 over 1. So my reciprocal of 1 over 3 is 3 over 1. And if you want to double check, it's 1 times 3 is 3. And 3 times 1 is 3. And that equals 1. And that fits my definition of what a reciprocal is. What about 5/7? Well, let's use our trick of flipping 5/7. Well, if we flip 5/7, it's going to be 7/5. And again, 5 times 7 is 35. 7 times 5 is 35. So it's 35 over 35. Anything over itself is 1. So definitely our reciprocal of 5/7 is 7/5. The last little bit I want to talk about in this video lecture is some geometry. So we do have some formulas that we use for area and perimeter, but they're different depending on the shape that we want to find out what our perimeter is and what our area is. For a square, our perimeter is going to be walking along the outside of our square. So it's going to be S times S, or S plus S plus S plus S. Right? So I'm walking along the outside. Well, if we want to shortcut that, that's S plus S plus S plus S, that's 4 S's, well, we can say 4 times S. For a perimeter of a square, our formula is 4S. Now our area is going to be the side times the side. So it's going to be side squared. For a rectangle, if I did that same trick of the perimeter, it's going to be just going to start off with the bottom L, the length, plus the width, plus another length, plus another width. So our perimeter formula is going to be 2L plus 2W. If you also want to think about this, you can say that it's 2 times L plus W, the quantity, if it was in parentheses. But standard is just 2L plus 2W. The area is going to be the length times the width to get the area. A triangle, the perimeter is we're just walking along the outside of the triangle, so it's each length A plus length B plus length C to get all the way around the triangle. So A plus B plus C, just the 3 sides added up. The area, on the other hand, is going to be 1/2 base times height. And if you want to refresh on how we get these formulas, there's some other videos out there, and I'll point those to you in our class structure. But these are just formulas that you should memorize. You should be able to use them when there's either letters or numbers with our geometry shape. So that's it for this lecture. Until next time, be seeing you.